Next, we learn relative humidity and dew point temperature. So, this red curve is the saturation vapor pressure, indicates ability or capacity of air holding water vapor molecules. Yeah. So, if actually water vapor molecule in the air is so much that produce vapor pressure to the weight of water molecules in the air is not saturated. What is relative humidity? Yeah. So the relative humidity is the ratio of actual vapor pressure over saturation vapor pressure. Yeah. So if not saturated, this ratio is less than 1. If saturated, this ratio is 1. Relative humidity is 100%. This red curve, this red curve indicates water vapor condense into the liquid water because it's saturated. Yeah. So this is the relative humidity, vapor pressure, and the saturation vapor pressure, the relationship. So here is the relative humidity formula for is the ratio of actual vapor pressure over saturation vapor pressure is not saturated right now. And so how to make this air saturated? There are a few ways, different ways. Yeah. So you can evaporate more water molecule into the air. So this dot will going up, right? More water molecules in the air. So the weight of water vapor molecules is going up, vapor pressure is going up, then until touch the red curve, then it becomes saturated. On another way, this fixed temperature keep the temperature 30 degrees C. Just add or evaporate more water molecules into the air. So another way, we do not add more water molecules into the air. Yeah. So we fix this amount of water vapor molecules in the air. How can you make this air saturated? Yeah. Do you know? Cooling. Yeah. So you can cooling this air to 20 degrees C. 20 degrees C. Wow. So you can this become saturated. Yeah. 20 degrees C. Then become saturated. That is the saturation vapor pressure. This temperature, 20 degrees C, is called dew point temperature. Yeah, that is dew point temperature. That air is not saturated. Then cooling. Then make this air saturated. That saturated temperature we call dew point temperature. Dew point temperature definition: temperature to which a given parcel of air must be cooled for water vapor to condense into water. Yeah, this is definition. Dew point temperature. Dew point temperature is the temperature, yeah, to which, yeah, a given part of air must be cool for water vapor to condense into water. Yeah, this is dew. Where there's so many dew on the bottle. Because see this S, this temperature is cool. Temperature is cool. This air become from unsaturated, become saturated. Then the water vapor condense into the dew. Yeah, that's dew point temperature. Dew point temperature is so important. So we must use more example to understand what the physical meaning. So here you see at 40 degrees C, this is the vapor pressure. It's very low. Not many water molecules in the air, right? Has a long way to become saturated at 40 degrees C. So how so we can cool this part of air to become saturated? Yeah, here. So this is the dew point temperature, 10 degrees C. So if we added more water molecules into the air, so this vapor pressure become larger. This is going up, right? Yeah, going up. More water molecules evaporate into the air, so this evapotranspiration become larger, right? Okay, so however, not saturated yet. So how by cooling the temperature become saturated, right? Yeah. So, wow. This temperature is the dew point temperature, 26 degrees C. You see more water molecules in the air. Oh, dew point temperature is higher. So, let's add more water molecules into the air. Yeah, almost saturated. However, not saturated. What's the dew point temperature? Yeah. Wow. 34 degrees C. From here, we can understand what does it mean, dew point temperature. If we add more water molecules in air, dew point temperature is higher. If less water molecules in the air, dew point temperature is lower. So, what does it mean, dew point temperature? Dew point temperature indicates how much water molecules in the air. Dew point temperature is higher, that means more water molecules in the air. Dew point temperature is lower, that means less water molecules in the air. Dew point temperature means water molecules. How much water molecules in the air? Wow. Yeah, that's dew point. Back to this chart. Yeah. So is this temperature 43? Is temperature. Temperature determines the capacity of air holding water vapor. Yeah, just like the glass. Glass doesn't matter how much water in the glass. However, that's how much water totally can hold. Yeah, the capacity. What is dew point temperature? Just like how much water, actually water in the glass. Yeah, dew point temperature indicates how much water vapor in the air. So that is the dew point temperature. The difference between temperature and dew point temperature. Temperature determines the capacity, the maximum of air holding the water vapor. Dew point temperature determines that tell us how much water vapor actually in the air. Yeah. So relative humidity is relative between dew point temperature and temperature. If temperature is equal dew point temperature, that means full the water of the glass. That means relative humidity is 100%, very humid. If dew point temperature is low, temperature is high, that means very dry. Relative humidity is very low. That's understanding about global warming. Global warming, air become hot. Air become hot, air can hold more water molecules. Air hold more water molecules, so when these water molecules condense into liquid water, can produce heavier rain. That produce is huge flooding. And the high category of hurricane or more hurricane appear in the same time. Yeah. And also, so huge water molecules condense into liquid water, they will release more latent heat. More latent heat, that is energy. That makes a storm, hurricane stronger, more violent. Yeah. You know, this hot air, they can hold more water molecules. That cannot be recharged in a short time period. From rain to rain in a longer time. That's a longer time for the plants. Yeah, that would be problem. That's dry. That's a drought. Yeah. So that will produce extreme drought events. You see, these extreme weather are the consequences of global warming. Yeah, global warming is the basic fundamental causes of extreme weather, extreme climates, and a lot of problem. Yeah. Here we introduce another concept, vapor pressure deficit. Vapor pressure deficit, this is the temperature, this is the saturation vapor pressure. So, yeah, we know this is saturation vapor pressure curve. Yeah. So, and this air temperature. So, we have uh, vapor pressure. Yeah, actually, how much water vapor in the air. And so this is the saturation vapor pressure. So you see there's a difference between them. Yeah. So this difference we call the vapor pressure deficit. Yeah. So that is this vapor pressure deficit is larger. That means dry. Yeah. Not good for the plants, for the trees, for the vegetables, for the crops. Yeah. So that's vapor pressure deficit. Yeah. So why in California is so frequently so stronger wildfire? Yeah. So some scientists then calculated this California VPD, vapor pressure deficit. Recently, then you can see there's a trend. This VPD has been increased. That's dry. That's create a risk of this wildfire. Yeah. So yeah, I give comments in Twitter. Hot air holds more water vapor, but with less increased chance for the yeah eh, yeah air can hold more water molecules. However, the water molecule is not abundant. Yeah, so that's become drier and drier, creates chance risk of wildfire.